There is an answer to that, and there's a proper way to do that. This is what this shows you. Let's take apart these two words. Significant. What does significant mean? Significant means important. Something you better keep track of. What does digit mean? Okay, well, it's a number. So in science, there's very important numbers that you have to keep track of in order to record your answer correctly. Because if you don't record it correctly, it's wrong. What do I mean by that? All of you, grab your calculator. I want every single one of you to use your calculator on this very simple problem. All of you, take 70 and divide by 21.23. What I want you to do now is on your notes, write down the answer that you would submit if this was a quiz problem or a test problem. What would you record as your final answer? Okay, I normally don't do this. I do it once in a while. I need a volunteer. Somebody, be brave. Don't turn your video on. I don't want to see your face. But I do want to know what the answer is. Carly.
It's Corelli.
Oh, it is?
Yeah.
I can barely see it. Go ahead.
But I would put 3.3.
She says 3.3. Anybody else brave enough? Come on.
I got 3.3 too. I'd put that.
Good. Anybody else?
My calculator gave me a fraction.
Oh, you better fix that. We don't record fractions in science. You... I would throw that thing in the garbage can. Dude, you got to get out of that fraction thing. It's a setting in your calculator. Anybody else want to give me their final answer? Don't worry, you're going to be wrong. Because the first two people are wrong.
I got 3.297.
Oh, beautiful! You're wrong. Okay, here we go. Yeah, you're all wrong. You've never had this before. That's why this is a very important day for us. The actual answer that you would record and actually get it right is only 3. If you add anything else, like a decimal and then some more numbers, it's wrong. I hate to tell you this, I really do. You've been wrong for decades. No one has taught you how to use measured values in calculations to record the correct answer. Your calculator is wrong. When it comes to the final answer, believe it or not, you are in charge of the final answer. The calculator doesn't know what's going on. It's going to take numbers and perform the math you want it to perform. But what your calculator does not know is significant digits. That's the problem. So today's lesson, dude, you got to figure this out. We have to figure out why the answer is just 3 and not 3.23854.325. One more thing. I know what you guys have done. I've been teaching a long time. I know what you do. You look at your answer and you go, let's see, I want to make this answer look good. I want to make it look pretty. I want to make it look like I'm smart. I'm going to add a couple numbers. Wrong. You never dress up an answer to make it look right. Because if you do, it's wrong. That's topic 2, my friends. Let's go. I'm excited. Okay, so now your question is, holy smokes, man. This old man's right. I have never seen this before. What causes these significant digits to show up? Well, you're in science class, and you know what you do in science class. You grab some tool, you go back in the lab, and you make and perform some measurement. You then sit down with your friends and you do some calculations. And when you do those two together, oh, you did it now, man. You made these show up. And I asked the math teachers at North, I said, how do you handle significant digits? And they looked at me like I was stupid. They looked at me like, what's a significant digit? And I just walked away because I know what math teachers do. Math teachers really don't give you guys a bunch of tools to go back and measure things and then use those measurements and calculations. It's not their fault, it's just the nature of the beast. But you're in science now, man. You're in trouble. Okay, measurements. Boy, I wish we were in person. I'd send you back in the lab. You're in the lab more than anything else in my class, but oh, this sucks. Okay, so if you were in my class with the burnt part of my ceiling, measurements, dude, you'd go back and you would grab a graduated cylinder and you would use it to measure volume. You would grab probably a ruler and you would probably go measure some length of an object. You would grab a tool called a balance, and you would use that balance to find the mass of some object or something we're working with. You would then grab your lab partner. You would sit down and you would begin to do some calculations. A simple calculation. I hope you guys aren't copying this. I'm sorry. You don't need to copy this. I'm sorry. I'll tell you what to write. And if you don't know, please ask me. Today's lesson, you have very little to write, but you've got a lot to think about and process. Sorry about that. So you would use a cylinder, use a ruler, a balance, whatever, go measure something, grab your partner, sit down, and begin some calculations. Let's say you're calculating density, which is a simple calculation. Usually we use it on freshmen just to get them started. And density is easy. You just simply take some measured mass and divide it by some measured volume. Grab your calculator and perform the math. Your mass came from some tool called a balance. Your volume came from some tool made to measure volume like a cylinder. When you put these two guys together, significant digits show up, and you have to know what that means in terms of your final answer. So, how did I get just 3 for that final answer? Watch and listen carefully. My friends, there's rules. No, don't. I don't want you to copy a single thing. Man, I need you so focused on this, I can't have you doing something else. Just read it. Think about it. Process it. I'll put this in Canvas. I'll copy all this stuff for you. You better print it off. Okay. Rules. There's rules when it comes to measured values, like from a lab. Rule number 1, if you're going to use a tool to measure something and digits other than 0 show up in some measured value, all of those digits are significant, which means they're important for me to determine my final answer in the end. Example, I'm glad you asked. There they are. Here's where I want you to think, mentally think. Don't write this down. I want you to look at these measured values, apply the rule, and determine how many significant digits are there. All of you, take a look at those two, mentally get your answer, and then we will check it out. This one's easy. Okay, let's take a look at the answers. I hope you have your answers for those two measure values because my answers are 2 and 3. So if I'm using a balance and I get 96 grams, boy, both of those numbers are going to be important for me when I sit down with my partner and do some kind of calculation using my calculator. And then I see 3 in here. This rule number 1 is very simple, but important. Rule 2, read it. Think about it. Zeros between two other significant digits are always significant. They're important for me. I have to know about them in order for me to correctly record my answer. Examples. Again, you guys just look, apply the rule, and think. This one's easy. Oh no, here comes my cat. You stay away. Okay, she left. Got your answers? Let's see, 5.029. According to this rule, yeah, all 4 of those count. Oh. By now, if you're paying attention and not sitting there on your phone texting somebody, you now know which digit or number you need to watch out for. If you're not paying attention, well, good luck, suckers. Number 3, here you go. Now we get in trouble. You're not used to these, that's all. You're smart, you just haven't had this before. Ooh, you will measure things in science where you have a bunch of leading zeros. Well, if you do, those are not significant. I do not worry about those when it comes to my final answer. What do those look like? Look at the rule, man. Look at the rule. Leading zeros. That's zeros in front, is what that means. Zeros in front. Oh, I see. I get it now. No. 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 Yes. 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 You know, I'll tell you this. You will never look at measured values the same ever again after we finish this. Because there's a lot of information in measured values that you have to pick up on. Number 4. Okay, we're going to go the other way now. Number 3 was leading zeros. Now we're going to go with trailing zeros. And, my friends, there are zeros after the decimal. What do they look like? Look, think, get your answer. My answers are 5 for the first one. Oh yeah, you see those zeros? They are definitely trailing, and they are after the decimal. Oh, I need those 3. Those 3 count. So this tool that's used to measure mass, it's telling you, hey, sucker, I can measure out this far. I can measure out that far, and when I did measure out that far, it just happened to be zeros. But I can measure that far. This balance can go out that far. It's showing you that. This one down here, This is also telling you, hey, I can measure out this far. That's why I wrote those zeros, and they're after a decimal. I can measure out that far, but when I did for this object, it happened to be right on. It happened to be zeros. Weird, I know. Weird. Well, so was number 5. Students don't like number 5. Well, actually, students don't like this period, but welcome to a higher level science class. You can do this. Trailing zeros. Oh no! Yeah, well, now they're trailing with no decimal anywhere in the value. Take a look. If you notice, there's no decimal in here. That is a sign, a signal to you. You better be careful with these measured values, because these tools round, and you really don't know what the real answer is. It's going to be rounded for you. So if you take a look at 7,000 grams, this scale rounds things up to only the 1,000 spot, and that's it. If you put this object on a different scale, you might see 6,952 grams. But you plop it on this scale, the scale goes boop, 7,000. Weird. Okay, number of significant digits in those two. Yeah, they each have 1. That's where students get in trouble, because you like to make answers look better, look more accurate. Well, when you start doing that, you actually get the answer wrong. Don't dress up numbers to make them look good, because now they're wrong. 6. Oh man, we're going to use scientific notation. Holy smokes, in this class, yes you will. Well, it's an easy rule. It's very nice. Hey, whenever the answer is in significant digits, whatever you see there, they count. They always count. That rule is, it's nice, because if I look at this first one, that 1, that 7, that 0, and that 0, hey, all 4 of those are significant or important to me when I do calculations. There's your answer. Don't worry, you only have 15 rules minus 8. So last one. Woohoo! Last one. Ooh. Uh-oh. Wait. No. Significant digits are not included when you count something. When you count something, are you using some man-made tool to count that? No. We don't have, that's hard to say. We don't have man-made tools to count something. And if you're not using a tool, then we don't need to keep track of significant digits, because it's been counted. There's no rounding. I just counted. So, dude, if I have 200 paper clips and they were counted, I don't even keep track of significant digits. 151 books. I don't care. They're counted. I don't have to go to my drawer of my desk and take out a counting machine to count paper clips. I don't need a man-made tool for that. So, your question is, so what do we do with that? Well, just do this. Put none. Who cares? Find your notes. Find your pencil. Take this quiz, all of you. Take it. And I'll leave the rules right here in front of your face. Take it. 1 through 4 on the right-hand side. Look at those measured values carefully. Look at the rules on the left and figure out how many significant digits are in there. All right, my friends, go. Here comes my answers. Just check. Just check and see how well you did. Boy, I hope you're trying this. Boom. Probably a good time for me to pause and for you to ask me some questions. Wow, no questions. I'm very...
I got one.
Okay, good. Thank you. Go ahead.
How'd you get the 1 for number 2?
Okay, number 2. When I look at number 2 carefully, one thing I notice is I don't see a decimal. The next thing I notice is I got these zeros following a number 1 through 9 with no decimal. That tells me that that rule is this one right here. It's number 5. So hey, the person who measured this distance was using some tool that rounds things up into the hundreds. So this tool will only measure things in like 100 meters, 200 meters, 300 meters, and that's it. There is no 125 meters. This tool cannot do that. Good question. Any more? Don't be shy, you guys. This is your grade based on this work.
Okay, so I kind of don't know how we're getting the numbers exactly.
My answers?
Yeah.
Okay, so here's what you guys have got to do in steps. Like, take a look at number 1. The first thing you guys should do is look where the zeros are. It's going to be those zeros. Second thing I do, I look for the decimal if I have one. Now, in number 1, I see a 0 and then I see a decimal. So now I'm going to go over to my rules and find out where that is. Is that 0 significant? And I want to go right over to the left. Because I notice rule number 3 warns me about leading zeros. And sure enough, my friends, that 0 in front is leading everything. He's leading everything. He's in front of a decimal, which looks just like this guy right here. And according to that rule, that 0 in front does not count. This tool that measured this mass cannot measure things in this spot. It's not a good tool to measure large, heavy things. Okay, maybe I need to do this. You guys are not used to tools in science to know if it can measure certain spots or not. So, I have an example for you. Let's say that I come to your house and I pick every single one of you up in a big school bus. We get in the school bus together and we drive on I-5 going north. I know what you're thinking. You're thinking, yay, Woodburn outlet malls. No, we're going past that. We're going to continue to drive north. Past Woodburn, there is a truck weigh station. You've all seen it. You see the semi-trucks pull over there, and they weigh them. Well, that's where I would take you to show you a tool. That's really weird. We would pull over to that weigh station, and I would pick one of you and have you go stand on the scale that is made to measure a semi-truck. And we could see the display that would read out your weight. You step on that scale, we look at the readout, guess what your weight is for that tool? 0. That tool is not made to measure the weight of small objects. It has to be freaking huge, like a semi-truck scale. So that tool, scale, is not made to measure small things. You would show up as 0. You would have no significant digits in your weight. Now, I'm going to have to throw like 6 of you on there, maybe even 26 of you. I get 26 of you on that scale. Then that scale can pick up your weight. It'll start showing me significant digits. Only probably in the 1,000 spot. So it's probably going to be like number 5, that semi-truck scale. Just pretend that's pounds right there. 16 of you, yeah, you're going to be in the thousands. You're going to see a bunch of zeros in the readout. Semi-truck scale is not made to measure small things. That's what you have to do with measured values. How good is this tool? This tool, number 2, sucks. It only measures things in 100 spots. I hope that helps a little bit. Like, we could do the opposite. If I had you in class, I would grab a balance from the back of the room, and dude, I can barely put my finger on there, and I'm going to get numbers. I'll see some significant digits. Now, if I press too hard on that scale, I get zeros, because it can't handle too much weight. That's where the zeros show up. Okay? It depends on the tool that's being used. I hope that helps a little bit. Very difficult to show you this on a computer screen. It drives me crazy. Okay, let's go. You're doing good. At least you're trying. You're answering. You're asking me questions. Would you all please take care of the next 4? Oh, look at number 8. Come on, you're smart. Look at 8. No way. Boy, I must have been in a bad mood when I made 5 through 8. Boy, I threw those zeros in there, suckers. Come on. Answers, here they come. Oh, did you get number 5? 5, you counted cars. There are no significant digits in there. None. You don't need a man-made tool to go count something. Therefore, there's no significant digits in there. It doesn't matter. We don't have it. Ooh, look at 8. Yeah. Look at 8. Every single one of those zeros count. Well, look where they're at, man. Wow, that tool. Well, okay, hang on. That distance measured by this person with that tool, good heavens. I wish I owned that thing. Okay. Hey, this is your first time doing this. Remember, you've been wrong your entire life. I can't fix it in 25 minutes. It's going to take time to fix all the errors you've done your entire life when it comes to measured values. We'll get there. Now you're kind of going, oh my God, what's next? Well, guess what, suckers? This is the tip of the iceberg. Because Now what we have to do is we have to take these measured values, find out how many significant digits are in these values, perform some calculation, get the answer in a calculator, and change it. Just like that very first example I gave you where my answer was 3, and you guys kept on saying 3.235. Wrong. Sit down, get comfortable, because here comes the rules. When you apply measured values and significant digits in calculations. Here it is. Here's that very first one I gave you. And you rolled your eyes and thought I was stupid and crazy. Well, I might be stupid and crazy, but I need you to get this 3 correct. So, there's only 2 rules. No, don't write them. I will put them in Canvas for you. I would print that sucker off and have it with you the rest of the year. All right, let's investigate how I got 3 out of these measured values. Rule number 1. Whenever you perform calculations with measured values and the math that you're performing or using is multiplication and or division, the rule is simple. The answer is rounded to the same number of significant digits as the measurement with the least number of significant digits. You probably read that and go, what? Or you heard me and you go, what? Okay, hang on. All of you, grab your calculator. Hurry, pronto. All of you, let's try this one. Type it in, man. 7.55 times 0.34. Hurry, type it in, get your answer. Boom. That's probably sitting in your calculator. Well, maybe not the meter squared, but that's probably sitting there. That, my friends, is wrong. It is not the final answer. You have to apply rule number 1. You got to go back and say, oh, okay, now wait a minute. I'm performing multiplication. That's right there. I then have to find out in these original values, these original measured values, how many significant digits are in there. Once I know that, I got to find out which one is the least, which then determines what this answer looks like in the end. Did you follow that train? Well, take a look at the value of 0.34, this guy right here. According to the rules that we just went over, there's only 2 sigs in there. If you take a look at the 7.55 meters, according to the rules, there's 3 sigs in there. Well, according to the rule for multiplication, your answer has to be the one with the least number of significant digits, which, my friends, is this guy right here. This 0.34 determines your final answer. And I only see 2 sigs. All of you, look at your calculator, or look right here on the screen. You need to round this to only 2 sigs. You can't use all 4. You round this correctly to 2 significant digits. That, my friends, is your final answer. Do you see what this 6 did to that 5 in terms of rounding? Now remember, you have been rounding numbers since grade school, elementary school. Well, you need to use your rounding skills in chemistry now as a junior and senior. Let's try another one. Just relax. Let's try another one. So 2 and 3, maybe in your notes, you should write down your final answer. Get out your calculator, perform the math, look at the number of SIGs that are in there, find the guy with the least, those number of significant digits, change what's in your calculator to a final answer. Do that for 2 and 3. Now I know it's hard. You don't have the rules in front of you. If you can open up a tab and get to my canvas, you'll see those rules in there. I understand if we were in person, I would print those and you'd have them in front of you. I know that makes this an extra challenge. I wish I had a way to go back and forth. Well, let's just take a look and see. Every time you practice these, you're going to get better at them. There's my 2 final answers. Now, I know you don't have that sheet in front of you. So let me apply the rules to these measured values and see if it makes it a little clearer. Okay, you see this 2.10? Those rules that are on the previous page would tell me, yeah, there's 3 SIGs in here. This value of 0.70, if I had those rules in front of my face, I could find the rule and I would know there's only 2 in there. That's a leading, hey, that's a leading 0. Does not count. Hey, that's a trailing 0, but it's behind a number 1 through 9. Hey, that 0 counts. That's significant. And then based on this rule of multiplication and division, the answer can only be, has to be rounded to the one with the least, which is 2. That's why my answer is only in 2 significant digits. I had to cut it back, had to round, final answer. Doing the same thing. Ooh, good heavens. This 2.4526, there's 5 significant digits in there. This this 8.4 has 2 significant digits. Okay, I know how many there are in each value. Then I go back and look. Oh yeah, hey, I'm dividing. What's the rule for dividing? The guy with the least. Well, 2 will determine the size of my final answer. I type it in the calculator, I look at it, I round it, 2 SIGs. That's how I got the 0.30. Now again, that 0 is a trailing 0 to the right of the decimal. That sucker counts. And that's how I get my 2 SIGs. Let me show you one more thing, and then I'll take questions if you have some. Let's go back to this original problem that you're still mad at me about because you were wrong. Let's go back to this original one. And first of all, let's apply the significant digit rules to these measure values. 70. Significant digits in there? 1. I don't see a decimal. I got this trailing 0 with no decimal. That sucker does not count. That is the only significant digit. 21.23, that's an easy rule. There's no zeros in there. There's 4 in there. Okay, I got the number of Sigs. Now I look at the math. Yeah, I'm dividing. I love division. Oh, the rule, the guy with the least. I don't have a choice. My final answer can only be in one significant digit. Bam. Questions? Maybe your question is, can I still drop this class? Nope. I'll help you, man, but boy, you gotta work hard. This is where online classes are not easy. Because guess what you're doing tomorrow on your so-called day off? You're working. You're working on your 4 classes. Yeah, I know, tomorrow's your day off, but it's not a day off. That's why the district went to this 2-day-a-week thing. The days you're not in class are the days you get into Canvas, you start looking at practice problems, you start working them out, you start reading the rules, you review the rules, you do the practice sheet, you check my answer key, you then grab the assessment, and you get it done. Tomorrow is not a day off. That's how this schedule was built. Now you know what the adults were thinking when they made it just Tuesday, Thursday, or Wednesday, Friday. Well, where do we go from here? Well, we're not done, my favorite second period. This is only multiplication division. Yes, you're right. We got subtraction and addition. Sit down and relax. Here you go. Don't worry. This one usually students they like it. They like it because your elementary teachers were doing it right. They taught you the right way to do addition and subtraction. The only problem is you have to go back to elementary school to remember what they showed you. Because my daughter who teaches 3rd grade, she does this with her kids. Okay, let's take a look at the rule. When we add or subtract, answer is rounded to the same number of decimal places. Uh-oh. Now it's decimal places, my friends, not digits. Now I look for decimal places. And now I screwed myself up. Answer is rounded to the same number of decimal places as the measurement with the least number of decimal places. You can probably read that 5 times and still be confused. Even when I read it, I go, what the heck is this? All right, let me show you. Woohoo! Okay, take a look at this first one. Now, don't do the problem. You just better watch me. Just watch me. Watch. Back in elementary school, bless those teachers, they taught you line up the decimal, right? Line up that decimal. Add them down each column. Perfect. The only thing they didn't tell you back in elementary school, wait a minute, that is not the final answer when I have measured values. Take a look at this 349.0. Take a look at that measured distance or length. It doesn't have a number here. It doesn't have a number in that decimal place. Look right there. Ah, that's what that means. There's nothing here. This guy has one, and this guy has one, yes. But this one does not. That means in your final answer, you cannot have something here. Because this guy can't even measure out that far. How can you have a number that this one can't even measure to? So, if you want to read this to help you, this might help you. So, like I said, that 349.0, it only has one number to the right of the decimal. It doesn't have two like the other guys. Okay, well, that means that point, that 6 right there, that's got to go. Now, before you chuck it or erase it, round it. Use your rounding skills. What does that 6 do to that 7 in terms of rounding? Yeah, you're right. It bumps it to an 8. Boom. Oh, stop. There, my little red X. There, maybe that'll help you visualize. So I can't use that. So the 6 rounds it up. There's my final answer. Sorry about that. Bada boom, bada bing. 369.8. That's the correct answer. That's the correct answer. Quickly, all of you, every single one of you, hurry. Line up the decimal. Line up the decimal. Okay, I'll shut up. All right, go. Number 2. You can only have one number to the right of the decimal. You better not have 2 numbers to the right of the decimal. Number 3 looks like you better have only 1 number to the right of that decimal. Final answers? Okay. Silence means, yeah, okay, yeah, good. All right, so I'm a little worried about your rounding skills. I don't know. I don't know how good you are. If you forgot the rounding skills, yeah, you're going to be in trouble. Because now you've noticed you are rounding and rounding and rounding for the next 18 weeks. So, quickly, no, don't write this. Just take a look. I'm only going to spend about 5 minutes on this and I'm done. I'm going to go have lunch. All right, rounding. You're probably doing it wrong. Yes. Question.
for like the last one, for number 3, I think you put minus 17.3.
I
So
put
you're not adding, you're subtracting.
correct.
So
Yes, I
you-
am. Yeah, I am subtracting. So the rule is the same when you add or subtract. So hopefully in your calculator, you took 34.61 subtracting 17.3. Oh, what did I do? How did I get
Yeah.
51? Ah!
You will be 17.3.
Yeah, I just see it now on my calculator. How did I get 50? Oh, I added. Yeah, you're right. Yeah, you're right. I added. Well, thank you for catching that. Okay, I am definitely going to fix that. Sorry about that. Good, I'm glad. You know something, you guys? This is my first time teaching online, so I might make a mistake. That's okay. All right, so the answer for number 3 should be 17.3. Good, thank you. Well, I'll fix that for period 4. Too late for you guys. Rounding rules. I'm going to keep the same rules. Believe it or not, there's different ones. You don't want to know what they are. It'll drive you crazy. Let's keep it simple. Same rules that you had before. Same rules. If you're using numbers 0 to 4, if you're using that to round a number to the left, leave that number to the left alone. If you're using numbers 5 through 9 to round a number to the left, you better bump it up by 1. Same rules. You've had these since middle school. I didn't want to change you to the other rules because then you would want to kill me. This is a problem. I have noticed this as a major problem. Sometimes you guys don't know if you're supposed to keep a 0 or erase a 0. With significant digits, man, you need to know, do you erase a value once you've used it for rounding, or do you turn it to a 0? Maybe that caught some of your attention because, boy, this is huge. Okay, when you're rounding and you are rounding to the right of the decimal, you better erase those suckers. If you're on the left of the decimal, those numbers that you use to round, you turn them to a 0. If you don't, your answer is going to be so far off it's not even funny. Almost as funny as my last problem that I got wrong. Hi vey. Okay. All right. We have about what? When are we out of here? 11:30. All right. Let's do this. Let's just do the first 2. So would all of you please look at examples 1 and 2? Please, in your head or on your notes, would you please round number 1 and number 2 to only 3 significant digits in the end? Let's take a look at my answers for 1 and number 2. Number 1, if I was to round this number to 3 significant digits, that number 2 is my first significant digit. There's my second. There's my third. Hey, I'm rounding this spot, which means I have to go over one more, which is a 7. You should know what a 7 will do to that 6 in terms of rounding. According to the rule, bump it by 1. Number 2, oh no, number 2, hey, you're 3 significant digits. No, 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 it's not this. That is not a significant digit. Your first significant digit is the 2. Your second is that 3. Your third is that 3. There's the 3. Now, the 5. We don't want that 5 there. But before you erase it, because it's to the right of the decimal, use your rounding. And a 5 is going to bump that 3 to a 4. This is a great, these two, they're a great example of this right of the decimal. When you're done using it for rounding, you better erase it. Some students are turning those guys to zeros, and I'll tell you what, my favorite second period, you put a 0 behind that 4, now it's wrong, because your answer has 4 significant digits. Not good. Okay, I think I better stop here. Listen, I'm serious, man. Tomorrow is not a day off. You better get into Canvas because now your second topic is uploaded and ready to roll. You've got work to do. This is where online classes are hard because you have to initiate the work. You have to be organized with your time and try stuff. Without me, you have to. Okay, with that, my friends, I'm done. Great job. You got a lot of work to do. You better submit topic number 1 assessment. I'm grading those suckers today. I'm going to hang around for questions. If you don't have any, adios.
Have a good day.
All right, man. You too. Thanks.
There.
Hi, Sticks.
Hey, what's going on?
Nothing. My cousin got you now.
No. Who is this? Hang on. Let me see.
Sophia.
Oh, no. No, that's right. Right before my lunch. Hey. Hey. Shh. How's your classes?
I have math right now. It's complicated.
Hey. So you're a Tuesday, Thursday dingo head?
What?
You're a Tuesday, Thursday?
Yeah.
Okay, I just told this class tomorrow's not a day off for you, boss.
I know I work.
No, not work as in making money work. You have class work tomorrow.
No.
That's what Fridays are for.
Oh, yeah.
Okay, were you dumb, dumber, or dumbest? What? Which one were you?
Go this way. Neither.
Oh, okay. All right, well, you got work. You got schoolwork tomorrow.
Yep.
Not a day off.
Yeah. I know. I have a lot of homework.
Yeah, I bet. And hey, you only got 4 classes, but man, that work just starts piling on and on and on.
No one did.
Yeah.
We got the Honey Cheerios.
All right, I'm out to third period.
Today we
You're
Okay.
done.
Yep. Okay. Bye.
All right, we'll see you.